Let me share my screen. Okay, so last time I think we stopped here, right? So we discussed different types of linked lists, and before that we discuss the operations associated with single linked list, right? So we were able to write the program as well, right? So then we discuss different types of linked lists, double linked list, and then double linked list representation, and the basic operations associated with double linked list, and then circular linked list. So there we discuss two types of circular linked list, right? Singly linked list as circular, and a double linked list as circular. But so in your course, we will not discuss the operations in detail, even the algorithms, right? So just for the information, there are different types of linked lists available, and how it looks like, right? So so last time we did not discuss about the applications of we studied different type of linked list, but we need to understand. So what is the purpose of this, right? So so in array data structure, we discussed different practical applications, right? So in linked list, so here I tried to highlight some of the applications of linked list, especially focusing on computer science, right? So there are some applications focusing, applied in the real world as well, right? So here the first one is practical applications of linked list in computer science, right? So basically, linked list will help to implement stack and queues. So we will start discussing stack and queues in next few presentations, right? So by using a linked list, it will be able to implement stacks and queues, right? So and then implementation of graphs data structure. So linked list can be applied, and in computer science, dynamic memory allocation. So it's one of the application, right? So performing arithmetic operations on long integers. So to arithmetic operations on long integers. So we need to use linked list, right? So and manipulation of polynomials by storing constant in the node of the linked list. So that is again one of the application in computer science. So mainly linked list will be very useful, right? And also representing sparse matrices. So those are some of the applications, especially focusing on computer science. But when we look at applications of linked list in the real world, so there are many. Here I tried to highlight you some of the important applications. For example, in image viewers, so previous and next images. So in almost all image viewers, there is an option called previous and next. So those images are linked and can be accessed by the next and previous button. So linked list is can be applied for this kind of navigations, right? And also previous and next pages in web browsers. So that need to be, this the address need to be stored in somewhere. So where that linked list can be applied, right? So we can access the previous and next URL. Search in a web browser by pressing the back and next. So most popular available these options, right? So and the music players also, right? Songs in the music player are linked to the previous and next songs, right? So yeah, the navigation is very easy, right? So you can play songs either from starting or ending of the list, so like that, right? So for the easy navigation, we are using linked list, right? So, and GPS navigation systems, right? So, linked list can be used to store and manage a list of locations and routes, right? So, allowing users to easily navigate, right? So, basically, navigation related things, right? So, linked list can be applied, right? And also task scheduling, image processing, and file systems, symbolic tables, undo redo functionalities in most of the desktop publishing applications. So that can be applied. And speech recognition, polynomial representations, simulation of physical systems. So there are here I tried to mention few, but there are many real world applications of linked list, right? So with that, we can. I think I forgot to mention the time complexities of different algorithms, right? So I will update that, and I will share this total presentation with you for your reference, right? Okay. I think that is the only one I think lacking in this presentation. So I will include that into this presentation and share with you. I already shared this presentation with you, but after that I did some modifications. So I will update, I mean further, because time complexity is also missing in this presentation. So I will that also to this PowerPoint presentation and share with you. So with that, we completed, I think, all of the discussions related to linked list, right? So now it is time to start other data structures. So far, we discussed about arrays and linked list. So now the next data structure, as per your syllabus, is queues, right? So let me open the presentation. So in the meantime, if you have any questions, right, anything to be clarified or any concerns, please raise your hand. So then I will ask you to speak, right? So that is easy. So please keep that discipline in this online lecture, throughout the online lecture, right? Okay, so let me share. Okay, queues, right? So this is the third data structure we are discussing in your class, right? So I think you are familiar with this word, right? Queue. So queue is again an abstract data structure like arrays and linked list. So it's kind of abstract data structure because it is built on the integrated data types, right? So queue is open at both ends. So it will be access to queue from the both ends, right? So like this, right? So it will be accessed by both ends from the front side and as well as the back side, right? So the queue is open at both ends. So one end is always used to insert data. So remember, with this diagram you can see to insert we cannot use both directions, only one direction, right? So and other end is used to remove data. So basically in a queue there are two ends, right? Both are open to access, right? So one end is always used to insert data. So we call enqueue, right? And the other end is used to remove data because dequeue, right? So therefore queues follows, right? First in, first out, right? FIFO. methodology. So first in, first out, right? So you can see the diagram, right? First in, first out. So this is the one we can remove first, right? First in, first out. So this is where the items can be inserted to the queue. This is where item can be removed from the queue. So one way, right? So therefore, queue follows first in, first out. So there are some other data structures. So in there, that is last in, first out. So LIFO, like that. So at the time I will explain that. So in a queue follows first in, first out rule or methodology, right? So that is the data item stored first will be accessed first, right? Data item stored first will be accessed first. That's why we call first in, first out, right? FIFO. So with this diagram, you can easily understand. So this is a queue, one way, right? So last in, last out, first in, first out, right? Okay, so now let's move into the queue representation. So now queue need to be represented. So there are many methods to represent queue, right? So it can be used array, linked list, pointer, and structures, data types, right? So we already learned about arrays and linked lists. So but in your syllabus, so we will discuss only array representation of queue, right? So maybe in your assignments, I will ask you to implement queue using linked list as well. But for the discussion, I will use array, right? Queue can be also implemented using array, linked list, pointer, and structures. So all the abstract data types, ADTs, right? So so that is the importance, right? I think in the applications of linked list, so I highlighted that it is one of the use, right? So that can be, I mean, linked list can be used to implement queue, right? So even there are many methods, right? So in this course, so we will implement queue using one-dimensional array, right? So you can see the same thing, right? Same representation, the queue representation with figures, right? So one side can be used to insert data, so other side can be used to out data, right? So insert, delete, right? So here you can see data elements. So these data items will be stored as array, right? So that is the first in, first out methodology. So where queue is practicing, right? Okay, let me move into the basic operations associated with queues, right? So there are 5 operations we will discuss, right? Enqueue, that is adding items to a queue. So add, store an item to the queue, right? So basically the insert operation, right? Adding elements to the queue. So then dequeue, so that is remove or access an item from the queue, right? So access and remove, right? So dequeue. So peek, get the element at front of the queue, we call peek, right? So get the element at front of the queue without removing it. So in this case, we are not removing, right? Just get or access the element at the front of the queue. And there are 2 other operations, right? Is full, that is to check if queue is full, because we are using array and there is a length of the array. So if the queue is full, we need to identify that. So is full can be used to check whether the queue is full or not, right? So that is full operation. Another one is empty. So that will use to check whether the queue is empty or not, right? So is empty and is full. So kind of checking operations, right? Okay, Okay, so in this discussion, so we will discuss all these basic operations. So there are some other operations as well, but to understand in your course, so we will discuss only these 5 operations. So enqueue, that is insert data; dequeue, that is to delete data; peek, access the first element, and then is full to check whether queue is full or not; is empty, check whether queue is empty or not. Right? So these are the operations we will discuss in this discussion. Okay. So okay, let's start with peek operation. So basically, peek is used to access the front of the queue, right? So here you can see how it looks like, right? So peek is help to see the data at the front of the queue, So that's where the item can be deleted at first, at front of the queue. So you can see a sample procedure of the peek, right? So begin procedure peek, return queue front. So we are accessing, as I said earlier, there are 2 things, right? Front and rear, right? Okay, so there are 2 ended, front and rear, right? So see here it will access the front element. So queue is there, it will access the front because that need to be it need to be identified the front and the back, both sides, right? So that point is there. So then with the peek operation, it will be access the front, right? Return queue front. So it will return the front element, right? Front element. So this is the implementation in C, right? So because it will provide the output. The peek is the procedure, right? And then start, and it will return the queue front, right? Okay, because we are defining front and rear, right, in the queue, and with that it will be able to access the front element. So that is the implementation using C. Okay, so the next one is full, right? So as I said earlier, is full is to check for the rear pointer to reach at the maximum size. So remember, so you can see, let's see. Okay, so this is the queue, right? Sample queue, right? Here you can see the elements, right? In this queue, there are 7 elements. So 7 elements are there, right? In this queue, right? So here there are the values, right? So in the queue, as we discussed earlier, there are 2 sides, right? So one is front. So this is front, right? And this is rear. Right? So can you remember in previous one, right? So we just access the front element, right? This one, because in the peek help to see the data at the front of the queue. So we are trying to access the front element, this one. So there you can see queue front, right? And this is the implementation. So in this full, so that will check for the rear pointer to reach at the max. So we are checking the rear reach the maximum size of the queue, right? So we are just checking the rear reached at max size. So max size is the array size, right? To determine the queue is full, right? So So this is the algorithm, right? So begin procedure is full, right? So if rear equals to max size, so this rear pointer is equal to max size, the rear size is equal to max size, so that is the size of the queue, it will return true. So that means full, right? Return true. Else returns false. That means queue is not full. And this is the end of if, and then this is the end of the procedure. So very easy, right? Begin procedure is full. If rear equal to max size, return true, else return false, right? So we are checking this rear, right, is reached to max size or not. If it is equal to max size, then okay, queue is full. If not, okay, return false, right? So queue is not full, right? Okay. Okay, let me clear drawings. Okay. So this is the implementation. Okay. So why? So with this, you may confuse because we are checking max size minus 1. Why? Because array index start with 0, right? So I think I hope you can remember it, right? So let's guess the same array, right? So because this if rear is equal to max size minus 1. Okay. Now think about this array, right? Okay. There are 1, 2, 3, 4, 5, 6, 7. So size is 7. Right? Size is 7. But index start with 0, right? 0, 1, 2. So this is the array index. 6, right? So therefore, we need to check. So other words, right? So because this is the first one, right? So 0. So this is the front, right? So the first element is 0. This is the front. This is the rear. Right? So then this is 0. The size of the array is 7, right? So this is the max size. This is the max size, right? This is the max size, and but index start with 0, and then you can see the front is 0, then 1, 2, 3, 4, 5, 6. Then we are checking this rear, right? If rear reach this max size, then it is full. But you can see the index is 6. Therefore, we need to check 7 minus 1. If rear is 7 minus 1, that means 6. Okay, the queue is full. Is that clear? That's why we are checking max size minus 1. 7 minus 1. Right? Equal to rear. Okay. Okay, let me clear all drawings. Okay. So this is the procedure to check. Actually, this is the C implementation of is full, right? So it will produce a Boolean output, right? So the output of the is full procedure, right? The function, the output is Boolean value, right? True or false. It is returning true or false. If rear is equal to max size minus 1, then return true, else return false. So this is the C implementation, right? So very easy. So just checking rear reach max size minus 1. So then return true, else return false. Okay. So the next one is empty. So we are checking whether the queue is empty or not. Okay, what is the procedure? So the procedure name is empty, right? So this is just the algorithm, right? So, but it's pretty close to the implementation, right? But this is the algorithm, right? So the procedure is empty to check whether the queue is empty or not, right? So if front is less than min or front is greater than rear, right? So that means it is empty, right? front is less than min or front is greater than rear, right? It will return true. Otherwise, it will return false. And this is the end of the if clause, and then this is the end of the procedure. Right? So very simple. If front is less than min or front is greater than rear, then return true. So that means the queue does not have any values. So that means it is empty queue. Otherwise, there are some elements that are not empty, right? So it will return the false, right? So anyway, the output is Boolean value, right? Okay, let's look at the implementation, right? Bool, that is the output of the procedure, is empty if front is less than 0. So because the index start with 0, I think you can remember that, right? For 0, front is greater than rear. So then return true. That means empty. This means empty, right? So the queue is empty. If not, not empty, right? Not empty, right? Okay, this is the C implementation of is empty operation of queue. Okay, now okay, now let's look at the enqueue operation. So one of the very important operations. So far we discussed about peek. So that is to access the front, right? Sorry, and is full to check whether the queue is full or not, right? And is empty to check whether queue is empty or not, right? So those will help to implement enqueue operation. So enqueue is to insert operations to an queue, right? So inserting element, right? Enqueue. So so as we discussed, queue is maintaining two data pointers, front and rear. So some values, right? So front, what is the front index? What is the rear index? Right? So with that we can identify, okay, so this is the front side of the queue and this is the rear side of the queue. So in an array, right? So array data structure, because here we implemented queue data structure using array, right? So so the following steps should be taken to enqueue, insert data to queue. So now you can think, right? So now we know is empty, is full, right? So by combination of these things, it will be able to implement the enqueue or algorithm of the enqueue, right? So let's see. Step 1, check if queue is full, right? So if the queue is full, there is no provision or space to insert values to the queue, right? So that need to be checked first. Check if queue is full. Okay, then if queue is full, then produce overflow error. So that means, okay, queue is full. So you cannot insert any element now, right? So it will produce overflow error and exit. So step 3, if queue is not full, okay. So that means it will be able to insert some values. So what will happen once we insert an element? So the rear will increase, right? So rear pointer increment. So it will increment rear pointer by 1, right? And then add data element to the queue location where rear is pointing. So once we identify the new rear pointer, so we will be able to insert the data element to the new rear, right? And then return success. So once you successfully insert, So then return success. So 5 steps. First, check if queue is full. Okay. If queue is full, then the step 2 will produce overflow error and exit. Right. So if queue is not full, okay, there's a space. Okay. Then increment rear pointer to point next empty space. Right. And step 4, add data element to the queue location where rear is pointing. So where the new rear is pointing, and then return success. Okay. The operation successfully completed. Right. So return success. Okay. Now you can see the insertion operation graphically, right? So this is before insert. So this is the queue before insert. Okay, there are 3 elements A, B, C in the queue. The front is pointing A, rear is pointing C. So now we are trying to insert for NQ. We are trying to execute NQ operation. So basically we are trying to insert new element called D to the queue. So basically we know the new element will be at the rear of the queue, right? So once you insert, you can see, okay, A, B, C, D. So those are the elements. And this is the new rear. The front is not changed, right? Because front side, we are not changing with the insert operation because we are inserting elements to the rear, right? Even there are 2 sides, we are inserting elements through the rear. Okay. And this is the algorithm for NQ operation. Okay. First, check if queue is full, right? If queue is full, that means it's full, right? Return overflow and end it. So from here it will stop, right? Otherwise, increment rear by 1 and insert the element to the new rear. So this is the data item we are going to insert, right? And return true and end procedure. Is that clear? This is the complete algorithm of NQ. Basically, insert element to queue, right? Procedure NQ. So we are passing the new element, new data element to be inserted. So in this procedure, right? When we are calling this procedure, okay, NQ, okay, let's say we are trying to insert data item called 100, okay, NQ 100. So then it will insert 100 to the queue, okay. Before inserting, so we need to check whether the queue is full or not, okay. So then call is full function, right, immediately. Is full. If this is true, then there is an overflow, right? Otherwise, increase the rear by 1, right? Increase the rear by 1 and insert the data element to the new rear, right? So here the rear is updated by 1, right? So then, okay, for example, the previous rear is 5. So new element that will be to the 6, right? So 5 plus 1, 6. And this is 6. Right? And return true end procedure. So very clear, right? We just look at the implementation of NQ, insert in C programming language. So same thing, right? So this algorithm is pretty close to the implementation. So therefore, I don't need to be explain this, right? So very easy, right? So in NQ, so we are passing value to this procedure, right? Because this is the data item to be add or inserted to the queue, right? So we are calling, okay, if is full, if the queue is full, then return 0. Else rear equal to rear plus 1. So this is the new rear. And now insert the data element to the new rear and return. Okay, success. This is the end of the procedure. So 1 means successfully inserted, 0 means not inserted due to some reason, right? So this is the implementation of NQ. Okay, let's move into the DQ. Right, this is delete. So from which end we are going to delete items in a queue? Obviously, that is the front, right? So inserting to rear, deleting from the front. Okay. So first, it needs to be checked whether the queue is empty. So then there is no item to delete, right? So no requirement if the queue is empty. So there is no DQ operations applicable, right? So that queue. So first check if queue is empty. If queue is empty, then produce underflow error. Okay. So some warning. Okay, nothing to be deleted, right? And exit. Step 3, if queue is not empty, access data where front is pointing. Okay, now we know front, right? So now delete. So access the front is pointing. And then step 3, increment from pointer to point next available data element. Okay, now there is new front, right? So then that need to be pointed. That need to be reflected clearly and then return success. Okay, so very simple. It's almost similar to NQ, right? So, but doing the opposite side, right? So previously with the NQ, we inserted data element to a queue. With the DQ, we are going to remove, right? But so the algorithm looks like same, right? So check if queue is empty. If queue is empty, produce underflow error or exit. If queue is not empty, access data element where front is pointing. And then increment pointer to point next available data element in the queue. And then return success. Okay, done. So this is the algorithm of DQ operation. So now graphically you can see what is happening there, right? So this is before, that means the original queue. So with 4 items, okay, A, B, C, D, front is pointing to A, rear is pointing to D, right? So okay, what will happen after deleting? Okay, from which end we are going to delete? So it should be front. Okay, that means the element A will be deleted, right? So okay, so then after, okay, D, C, D are there, A removed with the DQ operation and point front to the new front. So now what is the new front? That is B. Then now front will reflect the new pointer. I mean the new front, right? So that is DQ. This process is called DQ. Delete. So this is the algorithm, so generic algorithm for DQ operation. So procedure, that is DQ. If Q is empty, return underflow error, and if and it will assign Q front to data. So if I want to access this remove data, so then that need to be assigned. So the variable called data, so it will assign the queue before deleting, right? And then it will increment front by 1, right? So the return true and proceed. Right? Now look at the implementation. using C, right? Basically, this will give you, sorry, this will return the deleted item as well, right? So this code segment, this procedure return the deleted data item. So that's why it will give this output in DQ, right? If is empty, then return 0 underflow. So then it will assign Q prompt to this variable and increment prompt by 1 and return data because the deleted item is returning, right? So it will delete the item as well as it will return, it will give the output as well, right? So return data. With the return data, it will out the data. So in that way, the item remove as well as return, right? So that data maybe that can be used in some other purposes, right? So like that. So this is the implementation of DQ operation using C programming language, right? Okay, now let's look at the complete implementation of this, right? So complete code segment that can be used to implement the queue as well as it is associated operations. So we discuss a few operations, right? So this is the code segment. Let me okay, this is the output. So once we implemented this, so you can see this output, right? So let me share the total code segment, right, related to queue. And also, I would like to introduce this editor. So now at the beginning, actually, we use Notepad or WordPad and use GCC compiler, right? So I know it is time consuming, but for your understanding, it is very important. So then you understand from the beginning, right? So at the beginning, you use Notepad and then command line to compile C source codes, right? So now you know how it is happening. So, but this project is very interesting. Called, I think some of you may already using this. So this code blocks software, right? So that can be used to. It is a free C, C++, and Fortran IDE, right? So then you can use the interface to compile. So that is very easy and color coded. So you can easily understand the syntax, right? So the grammar very easily. So let me download this and install. That is that may be very easy for us, right? So remember when you are downloading, so please try to that is code blocks with MinGW because we need compiler, right? So I think the editor itself we cannot do anything. So the compiler should be there. So MinGW is the compiler. So therefore, it is very important. If you are installing code blocks, so please install it with MinGW. So yeah, where you can do your work very easily, right? So okay, this is code blocks with MinGW. Okay, I think in my machine MinGW is there as I can remember. Yes. Anyway, so I'm trying to download this. Okay, so it supports Windows 10, no problem. So the latest one is okay, this one. Okay, from any of the sources you will be able to download. Okay, this one. And also it is a very lightweight software, right? So So the file can be no problem. Because I just want to introduce this also, then it will easy your life. Okay, now downloaded. Can you see my screen clearly? So otherwise, oh, I already downloaded. Okay. If not, I can provide you Visual Studio, but I think you cannot run C using Visual Studio. I tried that, but you can do C++, but C, no. Right, but you can use Visual Studio Editor for writing codes, but compilation is not supported, right? So this is the code book setup. Okay, so I check all. So no changes. Direct. I mean, you can install the software very easily, right? So there is nothing to change. So if you have time, please download it and install. So then and in future classes we will use this software, right? So now we are gradually progressing. So our development environment, right? So at the beginning we started with Notepad and use GCC, and the last time we used Visual Studio, I think, as I can remember, editor, right? And then used GCC compiler. So now from today onwards we are using CodeBlocks, right? So do you want to run? Yes. Okay, done. So now let's open CodeBlocks. Okay, it is loading. So since I already installed MinTW, so GNU GCC compiler is detected, right? So current default compiler is GNU GCC compiler, right? So that means the compiler is there. So let's wait to load the software. So it loaded to my other screen, right? Okay. So this is the development environment, right? So this open source cross-platform, right? So you can access the same software from other operating systems as well, right? So this is CodeBlocks, open source cross-platform IDE. Version is 20.03, right? So these are the developers. Okay. So now this is my workspace, right? So okay, let's try to open new empty file, right? And save it as C or C++ file. Okay, let me save this file somewhere. Okay, let me. Okay. So I'm creating. Okay, just type some testing one, right? To just to check the program is working fine, right? So Okay. And then, okay. Okay, let's try to write some code segment. Just copy paste. Right. So this is first program, right? So here to check whether this is working. So you can see. So comments that is in green color, right? And you can see keywords and the statements, right? Okay. So here you can see code segments, right? So code blocks and with the correct indentation, right? Okay. So now, so you can run this program from here onwards, right? So you can build and run or just run. So once it will compile as well, right? Build and run. Okay, let's try to run. It seems that file has not been built yet. So do you want to build it? Yes. So now it is compiling and give you the output, right? So okay. So perfect. It is working, right? So let's use this software from here onwards, right? So to compile C codes, right? Okay, now I'm trying to, so now our target is to access the complete queue operations, right? From the beginning, right? So, okay, let me open this one, right? Queue code. So since we don't have much time, so I'm just opening this, right? The complete code here, okay? So then a new file, right? So empty file. Okay, save this as okay, queue. Right? And this is file types. You can see you can do many and also you can see you can use this for some other programming languages as well, right? So you can use this for Java and Fortran, right? Also you can handle Visual Studio products as well, right? So since this is free, so I recommend to use this, right? So queue and then save. Okay, now it is saved, and then this is the code segment, right? Right. So I will share this code segment with you, but before that, let's try to understand this code segment. I mean, the complete program, right? So here you can see. So all all the operations associated with queue, right, implemented using array, right? So these are the header files. So you know what is this, right? So these are the header files, right? So standard input output string, standard libraries, standard tools, so all are using here, right? So I think all are commented clearly, right? So then you can see. So here we are trying to define array with max equals 6, right? So then, so creating integer array, right? And now at the beginning, no elements. Now it is assigned front as 0, pre as -1. So that is the initialization of the queue, right? So with this, the queue initialize, right? So some other variables here item code. So that can be used in some. Okay, the first operation is in peak, right? So it is accessing the front element, right? So here we are trying to define other functions, right? So before implementing the main program. So you can see this main program, right? So here, somewhere here. Okay, this is the main program, right? So your battery is running low. Let me switch on this. Okay. Okay, so this is the main program, right? So this is the main program. So we are trying to call some of the procedures, right, inside this main program associated with queue, right? So this is the main program. So we will write this at the end, right? So now we define our array. Right? Now operations. So as procedures, right? So we will call these procedures inside the main program. Okay. So in peak is to access the first element, right? So then what should be returned? So return int front, right? Int array front, right? Int array front is empty. Return item count 0. Is full. Return item count max, right? Size, return item count. So okay, so the main part is insert, right? So now let's look at the implementation, right? So this is insert, and we need to ask the new value to be inserted. So in data, so this is integer value because we are working with integer array, right? So then first check is full, then if real, max -1, real -1, otherwise insert int array plus real data and then item count plus, right? So because we need to increment the item count, right? And remove data, right? Integer array from plus, right? If front equal to max, then front 0, then item count minus return data. So it is removing data, right? So with this you can see, right? So some data. Right. So, and now you can see the main program, right? So first we are trying to insert 3, insert 5, insert 9. Basically we are inserting element to the queue. Insert 3, insert 5, insert 9, insert 1, 12. Okay, now you can see the front value, right? 0. Real value is 5 because 5 elements, right? And then now you can see the indexes and the queue elements, right? To get understanding. Okay, we inserted the 3, 5, 9, 1, 12, 15. So index start with 0, right? So this is the first element, right? So this is actually the front, right? So this is the rear, right? So this is the front. Right? So this is the front and this is the rear, right? Okay, this is the front, this is the rear, right? Okay. Okay, remove data, sorry, okay. Is full, print queue is full, okay. Insert 16, 17, 18. So we are trying to insert some intermediate values here, right? And then print element at front, right? Print and print index, printf queue is empty, remove data. So this is the total code, right? So I will share this with you, right? And try to write this code, don't copy and paste, right? So try to understand the code segment and then try to write in simple way, right? Like this, right? Okay, now let's try to compile this. I hope there are no errors. Okay, there are some errors. So you can see while compiling, right? So okay, so no errors, and then at the you can see from the beginning, right? So this is the output, right? So let's open the main program. So this item, okay, up to 15, right? So you can see, okay, max size is there, right? Is full, right? So queue is full because So this size is 6, right? So 6 items are there. So then it is okay. After that, right, removing some items, right? Here, insert story. Okay, remove. Again, insert 16, right? Insert 17, 18, right? And then print element at front. Okay, you can see. And then print index values. And here also you can see execution time as well, right? So this is the actual running time, right? So execution time. So in seconds, 0.071, right? So this is the execution time of this program, right? Okay, so I will share this total code and try to understand the concept. So with the algorithm, you can understand what is happening there, right? So because I am sharing this PowerPoint also, right? So go through the PowerPoint and then go through the complete C code, right? And try to write your own code. So you don't need to write the exactly the same thing, right? So but you can refer these guides and type your own C code to implement this total queue, right? So it is kind of a assignment. So based on queue, so I will send it the assignment today itself. So I will give you 1 week. So by before next or not before next Friday. So you need to be up email to the address given. So still my LMS account is working, but so I have not enrolled for the courses, right? So this data structures and algorithms as well as human computer interaction. So still I have not enrolled. Therefore, I am not in a position to upload the assignments into the LMS. So till the issue will be resolved. So what I will do is I will send the assignments to Prabhashana, right? So like what we did earlier, right? So I will send the assignment to him. Basically, he will distribute among the other colleagues, right? So then you need to complete the complete code, compile, and send me the report, right? So basically, I'm asking a report, right? So basically, you need to send the code segment with your desired output, right? So basically, what I will do is I will copy because I am getting a digital version, and I will compare with the reports whether you copied from others or not. So if somebody copied from some others, so your marks will be deducted, right? So plagiarism will be checked for sure, right? So I will upload all 30 assignments and compare each one by one. So therefore, you need to write your own code, right? And I will copy the code and paste into this ID and see whether the program is running properly or not, right? So that I will check by myself, right? So check whether the desired output is there or not, right? So okay. So I think I did not send the assignment related to linked list. So I will send that one as well, but I will give you one more. So the deadline will be changed accordingly, right? So I am not asking 2 assignments or no before next Friday, right? So I will give sufficient time for your preparation, right? So don't worry about that, but try to do by yourself. You can ask from your friends. You can get the support from your friends. It is 100% okay, but don't try to send the friends code to me, right? So I need your code. So from that, I can understand you are doing this in a correct way, right? So if you are copying, so then that's a kind of problem for you, right? Not for me, because you are not learning. You are copying, right? So it is a different skill. Copying is a different skill. but it is not mentioned in your ILOs, right? So copying skill is not testing here. So some other objectives are there, right? So therefore, so I'm trying to give you that skills to you, but don't try to copy, right? It's also not a good habit, right? So keep that in mind and use this code blocks software to write your codes, right? So if you have some, best ID than this, so please use that, right? So it is your choice, but so I'm recommending this one, and this is a kind of good tool, right? So free open source software. Okay, so so if you have any questions related to this new data structure, you can ask. So if not, we can move into the stack data structure. So if you need some kind of, okay, now it took around 1.5 15 minutes plus 1 hour, okay, around 115 minutes hours. So if you need a kind of break, I can give, but I think it's better if we can start stack. And since this is online lecture, I know this is some kind of boring because so I'm speaking because the interaction is very poor. So therefore, sometimes you may get sleepy. So that I cannot observe because I cannot see your faces, right? So anyway, so if you are recording this lecture, I think you can. So I forgot to press recording, but I guess some of you may record this, right? And then you can refer this recording later. So if you have some, if you miss something, right? So that option is also there. Okay, so let me open. So, okay, I think I forgot to add some of the practical applications. Okay, let me add this slide as well. So to understand the importance of Q data structure, right? So that is very important to understand. And also I will add the time complexity of each of the operations. So that will help for you to understand how much resources will be required to run these operations. So that is also very important, very, very important. So here some common applications of Q data structure, right? So I think we learned about this. We need to understand. So what are the applications? So there are many. practical applications, for example, task scheduling, right? That can be used to schedule tasks based on priority or the order in which they were received, right? So we can organize this data in a queue data structure and do task scheduling in much more efficient way. Resource allocation, so queue can be used to manage and allocate resources such as printers and CPU processing time. So resource allocation also we can do. Batch processing, right? So queue can be used to handle batch processing jobs such as data analysis or image rendering. So all these data will be stored in a queue and do the processing much more easier way. And then message buffering, event handling, traffic management. So most of the activities related to performance. So the queue will play the main role, right? So remember, these are some of the common practical applications, right? So queue data structure, and also I will add time complexity for each of the operations into this same presentation. So that is missing here because that is also very important, right? So once we write the algorithm, we need to check the time complexity, right? So it's one of the crucial factor, right? So running time. So I will add a table for that. You can remember in the array also we did the same, right? So time complexity for each of the array operations. So like so time complexity for all queue operations. So I will add that to the same presentation, right? So with that, so we can complete the array data queue data structure, right? So far we completed the arrays, linked lists, and queue data structures. All are abstract data types, right? So derived from inbuilt data types in most of the programming languages, right? So we call abstract data types, right? Okay, let me open this is okay. Let me open and I will share this total code segment, right, to you, so you can practice. So I will send the PDF document of this, right? So this is the complete implementation of queue, right? So in a Word document. So I will send this as well, right? With the same lecture number, right? So you can see we are maintaining numbers, right? The introduction start with 0, and then data structure basics, algorithm basics, and C programming basics, right? So then we started with arrays, linked list. So today queue, right? So number 7. So the Word document also with the same number. So then so you can easily understand this, I mean, structure. I mean how these lecture notes arranged. So it will much helpful for you, right? So we need to start with stacks, right? So I will start that as well, the discussion. Okay, I think now you can see the PowerPoint presentation, right, in your screen. So today are you using common screen or I think individual, right? Okay. So you are using your computers, right? So not the smart screen, right? So okay. So last time we had a power issue and we are sorry about that. So I think today I understand that there are some issue with the network, right? So but the participation is very good. So there are 27 participants. So thank you for the participation, right? So I mean it's very important to participate because then you can obviously you can access the recording later. But so if you have anything to be clarified, so this is a good time, right? So you can raise your hand and you can ask any matters related to this discussion, right? Okay. So if you are bored, so let's take, I think, 10 minutes break. I think it's better. So you can uh, go around and uh, get some energy, right, to work with the next discussion, right? So I know these online lectures are so boring, but uh, today I don't have any other option, so that's why I chose this method of delivery of this course, right? So tomorrow also we will do the same, but next week definitely I will come to your campus, right? Uh, so okay, let's try to continue this series, and then we can have some discussion, right? So if you have anything to be clarified, so ask me now, or maybe next visit to your campus. So, so anytime I'm okay with that, right? So then face-to-face discussion is much more better than this kind of online lecture. So that I feel during last 2 3 years, right? So with these issues. Uh, but anyhow, we need to proceed and we need to complete your curriculum, right? And then ready for the exam and complete the semester, right? So, so we need to move forward. Okay, so let's take 10 minutes break. So we will start at 4:15. So get relaxed and then ready for the next discussion, right? So today I'm planning to drag this discussion up to 5:30, right? So we have another uh, around 1 and 30 minutes. So take 10 minutes break. So at least we have 1 hour and 15 minutes, right? So to complete the stacks, right? Okay, then thank you, and take 10 minutes break and come back and let me know once you're ready, right? So give me a message, or you can unmute and speak, right? So okay, we are ready. Okay, thanks. Shall we start? It took more than, I think, 15 minutes. Shall we start now?
Okay, sir.
Okay, thank you. Okay, now let's start stack data structure. So this is also ADT, abstract data type, right? So somewhat similar to queue, but the operation proceed is different, right? So stack is again abstract data type, we call ADT. So commonly used in most programming languages, so very popular. So stack operation, right? So commonly used in most programming languages. So it's behave like real world stack, right? So you can imagine, right, deck of cards or fill of plates, right? So but this allows operation at one end only. So can you remember in queue? So operation can be do both sides, right? So in queue, front and rear, there are two, right? So both ends, right? So in stack data structure allows operations at one end only. So we call top, right? So any given time, we can only access the top element of a stack. So top is the only place where we can access the stack, right? So simple, right? So at any given time, we can only access the top element of a stack. So the top, right? This feature make in last in first out. So because we are accessing top, right? So every time the elements are adding finally, last, right? So can access first, right? Last in first out, we call LIFO data structure. So LIFO methodology, right? So stack behaves as per the LIFO methodology. So right, last in first out. So in other words, we can say the element which is placed, inserted or added last is accessed first, right? Element which is placed last is accessed first. We call last in first out, LIFO. So in stack, insertion operation is called push, putting items to the stack. We call push, right? So removal operation is called pop, right? Popping up, right? So because insertion and removal operations are the major operations associated with any data structure, right? So can you remember the queue? So NQ, DQ. So likewise, push and pop, right? Push and pop, right? So insertion operation we call push, removal operation we call pop. So these are the two major operations associated with the stack, right? So here you can see the graphical representation, right? So this is a stack. One end is open, we call top, right? So last in item can be accessed first. So in other words, we can say first out, right? Last in, first out. So this is the stack, and these are the data elements, right? So in push operation, you can see pushing, right, data elements, right? So last inserted elements are at the top, right? So this we call push operation. So in the right hand side, you can see the pop operation, removing elements from a stack, right? We call pop operation. So push and pop, right? So these are the two major operations associated with a stack, right? Can you please wait 2-3 minutes? Okay, so like queue, stack operation, I mean, stack can be implemented by means of arrays or structure data type, pointer, and linked list, right? So also stack can either be fixed size or it may have sense of dynamic resizing, right? So once we define, we can define the stack size, or we can have a dynamic, I mean, the variable size, right? So a stack can be implemented by means of array, structure, pointer, and linked list. So I think last time we discussed queue, I mean, in last presentation. So that was implemented using array. So here also stack, we will use array to implement, but it is not limited to array, but can be used like linked list, structure data types, right, pointer. So those are the ways that can be implemented stack, right? So also the stack can be fixed size or variable size, right? So in this discussion, we are going to implement stack using array. So which makes it a fixed size stack implementation, fixed size stack implementation, right? So when we are using array, right? Okay, so we are discussing the basics of basic operations of stack, right? So we are using array with fixed size for this implementation, right? So basic operations associated with stack, right? So stack operations may involve initializing the stack using it and de-initializing it. So we need to initialize and de-initialize. So that is obvious, right? So once we define the array, right? So it is initializing, right? So apart from these basic stuff, a stack is used for the following two primary operations. So what I think we discussed this push and pop, right? So insert and delete, right? So push, that is pushing, storing, inserting an element on the stack. So push operation will help to pushing or storing an element on the stack, right? So pop, that is used to removing. Yeah, someone is raising hand. So what will be the issue? So you can speak and ask. So maybe mistakenly, or it's okay. If it is mistake, no problem. So if you still really have a question, please ask. No issue, right? Okay, so push, that is pushing or storing an element on the stack. So inserting elements, right? Pop, that is removing, right, an element from the stack. So can you remember peek? So that is get the top date element of the stack. So that is get the top date element of the stack without removing it. So in pop we are removing, in peek we are just accessing. So is full and is empty. So that is full is to check whether the stack is full or not. Is empty to check whether the stack is empty or not. Right? Is full is to check whether stack is full or not. Is empty to check whether stack is empty or not. Right? So similar to queue data structure. Right? So similar thing. I mean the idea is same, but the operation may be a little different because we can access one way, right? So only top element of the queue, right? So That is also important when we are understanding this. So these are the basic operations associated with stack: push, pop, peek, is full, and is empty. Okay, now let's discuss each of the operations individually, right? Okay. So always please remember, all times we maintain a pointer to the last push data on the stack. We call top, right? So we don't have front and rear in this case. No two ends, only one end. We call top, right? At all times we maintain a pointer to the last pushed data on the stack, right? The pointer always represent the top of the stack, hence name top. So generally we are calling top, right? So because the pointer is always representing the top of the stack, so hence we name it as a top. The top pointer provides top value of the stack without actually removing it. So remember this one, right? So peek, so it will access the first element, the top element of a stack, right? So the top pointer is provide the top value of the stack, right? So okay, peek, that is to access the top element. So since we are using array to implement stack, we are just accessing the stack top, right? Stack. So stack is the array, right? So top element. So because we are maintaining and pointer to this one, right? So top. So it will return once you call peek function, right? So it will return the top value of the stack, right? Begin procedure peek, return stack top, and procedure, right? This is the algorithm of peek function, right? Peek function. So this is the implementation of peek, right? Function in C programming, very easy. So this will basically provide output. So integer output, peek is the procedure, and then return stack top. So very similar to this algorithm, right? So it's full. So very easy. So this is algorithm of is full function. So this is the beginning of the procedure is full, right? So if it is checking this top equals to max size, so that means we reach the maximum number of elements in the stack. So then return true because this is full, right? So return true, else return false, and this is the end of the if clause, and this is the end of the procedure, right? So basically this will return true, right, if this equals to, I mean top equals to max size, otherwise false. So that means the stack is not empty, right? So these basic functions will be used in insert, I mean push and pop operations. That's why we are studying this first, right? So so peek and then is full, is empty. So we are studying first because we will apply these functions inside push and pop operations. So when we are discussing push and pop algorithms, so we will we definitely need to access these of the procedures, right? Because we need to check. For example, before inserting, we need to check whether the stack is full or not. So then we need to call this is full procedure, right? So based on the results, we can go ahead. Okay, it's full, is true. So then no provision, so overflow, right? So if top equals to max size of the queue, then return true. Otherwise, return false. And then there is the end of the program, right? And procedure. Okay, this is the complete implementation of is full function in C programming language. So you can see this is Boolean output because true or false, right? So then this is the output of this procedure is Boolean value. So it's full, right? So if top equals to max size, then return true. Otherwise, return false, right? So if top equals to max size, that means the stack is full. Otherwise, stack is not full, right? So true and false. We will give you the Boolean output. So it's empty. Sorry.